Hello, my name is Shailendra Chaudhary, and in this video I'll show how to create external DNS for automatic DNS record set creation. And we'll test this by using the host-based ingress routing in AKS. So let's start. We already have an AKS cluster, which is AKS demo cluster. Which has its own standard load balancer. I have bought a custom domain from a third-party website Ionos, which is mydevsecops.org. And first thing we'll do is we'll create a DNS zone so that we can manage this custom domain from Azure. The purpose of creating the external DNS in this video so that automatic host registration or DNS record sets are created whenever we define the ingress. But this can only happen if our AKS cluster has required permissions to make the changes in the DNS zone. So we'll provide the required permissions on the virtual machine scale sets for the node pool, which has its own managed identity created during the creation of the cluster. So we have virtual machine scale set, which has user defined managed identity, and we'll assign the role of contributor on the same resource group where DNS zone is created. And once the roles are assigned to the managed identity, AKS cluster can make changes in the DNS zone. To start with, we'll first create a namespace Ingress basic. So that all the resources which are created in this video will be in this namespace. And it will be easy for us to clean up once we are done with this demo. So using the Helm, I'll create the Ingress controller, which will have the two pods running. And once the Ingress controller is created, this will create a new public IP in the load balancer. And the use of the Ingress controller is to make the changes in the load balancer rules based on the ingress routing defined in the AKS cluster. Once the Ingress controller is created and its pods are up and running, then we'll create the external DNS using the Helm. And this will create the external DNS pod and service. Now these two services can fulfill what we want to achieve in this video, but I'll add the certificate manager to make our web pages more secure. So using the Helm, we'll create certificate manager, which will further create the pod and the service into the Ingress basic namespace. And then we'll define the letsencrypt issuer, which is a certifying authority, and will generate the certificate for our application. Now we are almost ready with the prerequisites. So then we have to create two applications, application 1 and application 2, along with their service, service 1, service 2. These are the cluster IP service, so that these applications are exposed internally. And finally, we'll create the ingress routing, which is host-based routing for both the applications. And once that is done, so there will be different changes which will be made. So the rules defined in the ingress for the different application will be defined in the load balancer using the ingress controller. DNS record sets, a record, will be created in the DNS zone using the external DNS. A new certificate will be generated for our domain name using the certificate manager. And finally, our application routing will be ready. If we have defined for application 1 like app1.mydevsecops.org or app2.mydevsecops.org. So app1 will go to the app1, it will show the web page defined in the app1, and app2 will show the web page defined in the app2. And this is what we want to achieve in this video. So let's check in demo. I'll be using the same AKS demo cluster which I have been using for the whole AKS series. So let's log into the Cloud Shell, kubectl get nodes. So these are the two nodes of the node pool of our AKS cluster. So before we start running the commands, I want to show you the blog post which I have created for this video. So by using this blog, it will be very easy for you to follow along. So it covers all the steps which I have just explained along with the commands and the YAML files which are required. So create a DNS zone, ingress controller, setting up the permissions, deploy external DNS. So let's start. First we'll create a DNS zone with the name mydevsecops.org and we'll create in the same AKS demo resource cluster resource group. Let's copy this and run. Let's check if the DNS zone is created. It took few seconds, but now a DNS zone is created. And it provides the name server. So the next step is to go to the third-party website from where you have purchased the domain and update the name servers there. So this is ionos.com from where I have purchased the domain. Let's make the name server changes here. Use the custom name servers and let me copy paste. Now the name servers are getting updated. It shows that it can take up to 48 hours, but this thing is pretty quick. So by the time we'll follow all the steps, I believe the name server should be updated. Let's go back to the blog post. So we'll create an Ingress controller. For creating the Ingress controller, we'll first create the namespace, which is Ingress basic. Let's create this namespace. Let's check if the namespace is created. And as you can see, Ingress basic namespace is created just 7 seconds before. And we'll add the repo for Ingress controller. And we are using the Helm to install the Ingress controller. The repo should already be there because I've used the same thing multiple times in the previous video. Now we'll update the repo. The repo is updated. And we'll run the Helm command to install the Ingress NGNX into the namespace Ingress basic, where the two pods will be created named as Ingress NGNX controller. So let's run this. This usually takes around half a minute because once the Ingress controller resources are created, it creates a public IP in the load balancer. So let's check kubectl get all in the namespace Ingress basic. So as you can see, Ingress NGNX controller and the admission controller are created and a public IP in the load balancer is created along with it. And there are two Ingress controller pods which we have defined in the deployment. So next we'll assign the permissions to the AKS cluster, which we'll do using the user defined managed identity for the VM scale set. So let's first go to the VM scale set. Virtual machine scale set. I will go to identity, user assigned identity. We can see there is a AKS demo cluster agent pool identity which is assigned here. So we have to add one more role to this user defined managed identity, and we'll do the role assignment so that managed identity will have required permission to make changes in the DNS zone. So first we'll assign some variables. We are fetching out some values. Like in this case, we are fetching out the tenant ID of our subscription, which is Visual Studio Enterprise subscription. So let's copy this. Let's check. You can also provide these values manually by copy pasting, but as we are following the command line, so it will be easy if we'll use all the commands to get all the value. And this will fetch out the subscription ID. This is our subscription ID. And this will fetch the details of the managed identity. So this is the ID. So let's check this. If we'll go to the virtual machine scale sets and identity and go to the user assign, and this is managed service identity. If we'll check the client ID, it's ending with 01F. And you can see here 01F. So now we'll find the DNS ID of the new DNS zone which we have created. So this is the whole path. Resource group, AKS demo, resource group, network in the DNS zone, mydevsecops.org. So once we'll have all these values, we'll assign the permissions. So we are assigning the DNS zone contributor level access so that it can make the changes in the DNS zone. So let's copy paste. And as you can see, now it has DNS zone contributor access. And these changes are made in the service principal, which is created when we create the user defined managed identity. So let's check. As you can see, DNS zone contributor access is provided. Now let's create the external DNS. First add the repo, which should already be there, but let's run it again. We'll update the repo. Successfully updated now. And we'll run the helm command to install the external DNS. Let's copy paste. So now we are installing the external DNS from the source which we have defined in the repo. Namespace is Ingress basic. In the Azure, the owner ID is AKS demo cluster, and the resource group is AKS demo resource group, and we are providing the tenant ID, subscription ID, and the managed identity details. We'll just run this part of the command so that we can check all the pods running in the Ingress namespace right now. So that's good. We have Ingress controller as well as the external DNS pod running. So now the next is installing the certificate manager. And first step is to make the changes in the label of the namespace so that it will disable the validation. So label is changed now. We'll add the repo. We'll update the repo now. Repo is updated. Before creating the certificate manager, we have to install the custom resource definition which are required by the certificate manager. So different certificate managers, cluster issuers and issuers are defined, which is prerequisite for installing the certificate manager. Now we are installing the certificate manager from the defined repo in the namespace Ingress basic with the version 1.7.1, which is the latest version right now. It took around 2 minutes and now the certificate manager is installed. So let's check kubectl get pods in the Ingress namespace. So now there are certificate manager pod, injector pod, CA authority injector pod, as well as the webhook, external DNS pod, and then GNX controller pod. So that's good. Let's go to the next step, which is creating an issuer. So let's create a cluster issuer, which is letsencrypt. And this will help in generating the certificate once we'll create the ingress. Let's copy the file name. It's a cluster, kind is cluster issuer, The name is Let's Encrypt. This is the Let's Encrypt URL. I provided my email ID and the class is nginx. Let's save and apply. So cluster issuer is created. Let's check kubectl. In the namespace ingress basic, get cluster issuer. And as you can see, Let's Encrypt cluster issuer is created. Now we'll run two different application 1 and application 2 along with the two different service for application 1 and application 2. These are the cluster IP service so that these applications will be exposed internally. So let's copy paste. So these are the two demo applications which you can find in Azure documentation too. This is AKS world is the name of the image, and we are using just AKS world 1 with the different title of the page and the cluster IP service. For the application 2, we are just changing the name to AKS world 2. Let's create another one. It's almost similar with the change in the title as well as the name. Let's save and apply in the namespace Ingress basic. As you can see, AKS Hello World 1 deployment is created, which will create the pod, and the service is also created, which is cluster IP service. So let's check kubectl get all in the namespace Ingress basic. So there are application pods, certificate manager pods, external DNS pods, and the Ingress controller pods. And for the two applications, there is a cluster IP service. Now finally, we'll create the Ingress, which will define the routing, certificate, as well as the DNS name. So let's copy the name first. So the kind is Ingress, where we are creating a hello world Ingress for the nginx, and the cluster issuer is Let's Encrypt. Two hosts which are defined, web1.mydevsecops. My bad, it's org. Let me make the changes. For the TLS certificate, two hosts are defined with the secret name as TLS secret. For the host 1, we are using the application 1 on port 80. For the host 2, which is web 2, we're using the application 2. And that's all. Let's apply. Ingress is created now. So let's check if the secret is created. And TLS secret is created here. And this is how we can describe a secret. So this secret is created now. So this is new certificate request. Now let's check in the DNS zone if the alias records are created. And as you can see, 4 records are created. 2 for web1, 2 for web2, which is alias in the text record. So let's test our application now. So open web1.mydevsecops.org in the browser. And here you can see this is the web page for the application 1. And let's test the another one. web2.mydevsecops.org. And as you can see the difference, there is a different web page. That means if we'll use the web1 as a prefix, it will go to the application 1. If we'll use the web2, it will go to application 2. And you can see the log sign. This means the TLS certificate is working fine and our website is secure. We are using the HTTPS now. That's great. We have successfully achieved the desired outcome. So to summarize this video, we first created the DNS zone so that we can manage the custom domain from the Azure. Then we created the Ingress controller. We created the external DNS. We created the certificate manager. But before that, we assigned permissions to the AKS cluster so that it can make changes to the DNS zone. And once that is done, we created 2 different applications, application 1, application 2, along with the service, which is cluster IP service. And then we defined the ingress route, where if we use the web1.custom domain, then it goes to application 1. When we use the web2, it goes to application 2. And it created the certificate, made changes in the DNS zone and the load balancer. And when we open those URL in the browser, we get the desired results. So that is all for this video. I hope you liked it. Please like and subscribe. Thank you so much.